All right, welcome guys. Please, I'm trying to set this camera. Comment on the comment section if you're live. All right, so we are going to start in a minute now. I want to set this camera. I'm having a problem setting the camera. All right, so comment on the comment section if you're there. Now we're going to start right now. Now, momentum. Good morning, guys. So momentum, without wasting much time, I want to commence. So when we're talking about momentum in physics, we're not going to waste much time here. All right. So let's say if this is there is an edge here, you can call this a knife edge. Now, if you are applying a force here, let's call it F1, and at the point you also apply the force here, let's call it F2, and somehow you apply another force here, let's call it F3, and again you apply another force here, let's call it F4. So what are all of these doing? They are trying to, this one here is trying to drag this metal rule in this direction. This one also, lifting it up, is trying to drag it in this direction. Whereas this one, lifting it up, is trying to drag it in this direction. And this one is trying to drag this metal rule down. Now, the rule we are going to follow is our time. This is 12, this is 6. Now, if you could remember, when the time is ticking, it is ticking normally in this direction. So the time goes in this direction. So because the time goes in this direction, we call it clockwise direction. Whereas if the direction of the clock happens to start going this form, or that route is still on that straight line, it means that the net force on this rule is 0. Why? Because this one and this one, this two is dragging the metal rule this side, whereas this one is dragging it this side. But because their power are the same thing, they have overcome each other. So hence, the net force in this metal rule is 0. And if it is 0, this metal rule is going to remain on straight line. The principle also states that the sum or the moment on the clockwise direction is equal to the moment on the what? Anti-clockwise direction. So if this moment is here, we are going to have that moment of what? Clockwise equals to moment of the anti-clockwise direction. Now, moment is equals to force multiplied by the perpendicular itself. Moment itself is equals to force multiplied by the perpendicular distance, or we can use those moving what? Clockwise. And this one is for those moving anti-clockwise. So it is equal to what? Each other. Now, what is this distance? What is perpendicular distance? The perpendicular distance we are talking about here is, for instance, you have a line here, and this falls on it. These two lines are perpendicular to each other. All right. Now, this force here, F, is multiplied by the perpendicular distance. Perpendicular distance is like this. All this distance here is the perpendicular distance. So, for instance, using this same metal rule that I have here, if this is force and force 1, and from this place to this place is assumed to be 3 meters. If it's assumed to be 3 meters, the moment here is equals to this force multiplied by the perpendicular distance. The perpendicular distance is from here, and the perpendicular distance must go to where its edge is, or where the meter rule balances. So we take it from here. So we have here now to become F1 multiplied by 3 meters. Assuming that we are given the value of the force, we will now put in maybe 2 Newton, it will now become 2 Newton multiplied by 3 and equals to. Let's also assume that this force here is given from here to this place is assumed to be 5 meters. Now, the moment here is going to be what? F multiplied by distance, which is what? 5 multiplied by 3. You understand? So that is what we mean by the principle of momentum. I'm going to finally look at questions type you are going to be seeing on your JAMB and also WAEC, GCE, and NECO. All right, so let's look at the first question from what we have here. Please share this live and don't forget to comment your question on the comment section. Or let me just sketch the question here. So let's assume now we have a line. If you have a line and this line, this metal rule is balanced here. And this metal rule is graduated from 1 to 50. But this is put on the 35. It is balanced on the 35. That is from 1 to this place is 35. So I'm going to put 35 over here. Now let's say that a force is applied here, which is what? W. All right. Now, if from here to here is 35, let's also say that from here to this place, let's now say that from this to this other point is going to be 10 meters. You see, it's going to be a blunder because if it's 35, element here, 35 from 50 is going to give us 5. So let's not put this 30. Let's just put it 15. Right? Now, we are now going to find this force. So if you are given this diagram, you're asked to get this force. So you are with me when I draw the diagram. You see everything that I have to apply there. So let's look at the diagram. From here, 1 to 50 has been given. That is the length of this meter rule. Now, you are given this force. That is what is pulling this on what? Clockwise direction. So clockwise direction is pulling it. Why this one is pulling it under anti-clockwise direction. And now, from here to here, to this knife edge, it is balanced here under 35 meters. And here is 15 meters. So in this case, you're asked to find the what? The weight that is pulling this force here. Let me know what you think on the comment section. Write your answer on the comment section. If you know the answer, drop it on the comment section. On what? 10 meters. 10 meters plus this 15 plus this will give us 50. That's what I get. So what is going to be the answer? So now this side, as you can see, this is dragging this under this anti-clockwise direction. I get it. It is dragging it under anti-clockwise direction. It should be moving this part. But this force is dragging it here. And this other force is dragging it on the clockwise direction. So the clockwise force is equal to what? The anti-clockwise force. On moment on the anti-clockwise force is equal to the moment on the anti-clockwise moment is equal to the anti-clockwise moment. So the moment here, remember, is equal to the force times the distance from this part. It is also equal to, at the anti-clockwise side, it is equal to the force times the perpendicular distance. Now we want to try to get the perpendicular distance here. So the force here is not given, it is given as W multiplied by, where is the perpendicular distance? You're not going to calculate the perpendicular distance from here. Now you're going to calculate it from the where the knife edge is balanced. So the knife edge is balanced here. So we need to get this from here to here is 35. And just this part alone has been found to be 15. So now 15 minus from 35, 35 minus from 15 is going to result to what? To 20. So it means that this part to this part is going to be 20 meters. Hence, the perpendicular distance here is 20 meters. If you have any question, let me know on the comment section. Now, the next is checking for the what? Anti-clockwise moment. So, anti-clockwise moment, the first times what? Perpendicular distance. Here's the force, 10 Newton, multiplied by the perpendicular distance is gotten from this balancing of ninth edge, which is from here to here is 5 meters. All right? 5 meters. So, let's work it out. Hence, this multiplied by is going to give us what? 20 W equals to 10 times 5 is going to give us what? 50. And now we divide by 20 divided by 20. Now this cancel this. W equals this cancel this. 5 over 2 is going to giving us 2.5. So here, the force acting here is what? 2.5. Now, when you calculate the force here and the force here, they are going to result to what? To be the same thing. Hence, they are going to what? Makes this to balance. So the force we are getting to be 2.5 Newton. All right. If you get the same answer, let me know in the comment section. If you get the same thing, let me know in the comment section. Thank you very much. Thank you very much. You're welcome. Welcome to live class. You're welcome to live class. You're welcome to live class. All right. So now, this is a simple of question. So I want to end this class as soon as possible. Now I'm going to go into. Let's look at this drawing. So let's say we have something here, and in this line, let's say that this is balanced point, and now we are saying from 1 to 100 meter edge. So if the 100 meter edge, what are we going to have here? Now let's assume that here there is a force here, and this force is unknown. And let's also assume there is another force over here, which makes an angle of 30 degrees. Now, let's assume that there is another force here, and this force, let's call it something like 10 Newton. I want to use a simple number so we can be able to calculate it. Now, having known this, let's also assume there's another force here, and this force is having also 30 degrees. All right. Now, if from here to this knife edge, where it is balanced, is at the center, which is 50 degrees, sorry, 50. Let me know the answer in the comment section. So if you can solve this, let me know in the comment section. In this case, an assignment. Now, the next question we have here says, we have this drawing. And the graph from here is 1 meter. And we have from here to this place is 1 meter. Now here is point G, and from here to this place is 1 meter. This point G, 1 meter, 1 meter. Now in this case, you're asked to what? In the diagram below, what's the value of W? So the value of W is what you're looking for. So quickly do this. Let me know an answer on the comment section. What's going to be the answer on the comment section? You're welcome. What you have on the comment section? So this is just the diagram. You have to find this W on the comment section. Now, what you have to know, the trick here is that look at where this is balanced. As you can see, it's balanced. This is a knife edge. So if you put a knife edge here and you balance, remember that this thing is supposed to be falling, because if you can link something like a stick and you balance it here, it's going to fall like this. I seen it. It's going to fall. But to make it not to fall, you have to lift it up here with a force. Let's specify the force. Yes, specify the force as 20 Newton. The force specified as 20 Newton. So you have to balance, you have to lift it up here at 20 Newton. But then you must not lift it up much. You also have to apply another weight here. Apply another weight here in order to balance that particular plane surface object to be at plane surface or at plane shape. Now, this W, you are looking for it. Now, it's just simple. No matter the fact that it is not in the middle part, you can still get your anti-clockwise and clockwise position. So if you look closely, you find out that this one is going clockwise, all right? And this one is going anti-clockwise. Now, according to it, we found that the formula says that the force on the clockwise moment is multiplied by the perpendicular distance is equal to the force anti-clockwise multiplied by the perpendicular distance. Now, from this one we are looking for, this force, where is the perpendicular distance? It must come from where it is balancing. That is, if you take it from this line back to here, this is the perpendicular distance. And from here to here is 1 meter. From here to here is 1 meter. So this whole place is going to give you what? 2 meters. And this is moving what? Clockwise. So this clockwise, the perpendicular distance is what? 2 meters. So here, having what? F unknown, which is W, multiplied by the distance. So see, going to lift it up here, going what? Anti-clockwise. So it is contrary the direction of the clock. So here, the force is 20 Newton, and the distance is just 1 meter multiplied by the perpendicular distance, which is 1. So here now, 2 multiplied by W is going to give us what? 2W equals 20 multiplied by 1, 20. Now we have just W divided by 2 divided by, which is the coefficient. Now this is equals to what? 10. 10 divided by 2 is going to give us 10 Newton. So this particular one, can you let me know in the comment section? Do you see the last solving? You guys saw the last solving. I will solve this one. If you saw the last solving, I think that my YouTube is having problems. But if you saw it, let me know in the comment section. All right. Stopping here. So if you saw the last question, let me know in the comment section. We are almost through. We are almost through. If you saw the last question, let me know in the comments. If you saw when I solved this on live, when I solved this, let me know in the comment section. Please, your assignment. So I don't think like comment on the comment section if you saw when I solved this. All right, so I want to help you on solving this assignment. So this assignment, you have to find this W over here. All right, so this meter rule is related from 1 to 100. Let me give you a tips on how you're going to solve it. Now, how you're going to solve this is, it's just the force acting on the moment on the clockwise and the moment on the anti-clockwise. That's just it. So have to denote the moment you have on the clockwise and on the anti-clockwise. Remember that the clockwise will be moving like this, following the time of the hand of the clock is ticking like this, while anti-clockwise will be moving like this. So if you look closely, this one is going like this, which is what? Clockwise. So clockwise. Whereas this one now is lifting this up, but it is not exactly anti-clockwise. Now you have to make this one here, these two, to be in a slit form. So according to resultant of a force, of a moment of a force, if you have something like this 30 degree, you need to make it to be straight like this under the 90 degree. So you have to change this, convert this force to a what? A perpendicular force. Convert this one to a perpendicular force. How can you do it? So the force under the horizontal component, want to do it on the horizontal, the force is going to multiply by the cos theta you have. So this force you have on this place, multiply by the cos theta, you're going to get it on the surface. It is no longer going to be here. It is now going to be in this point. All right. But here, we don't want it to be in this line. You want it to be in a vertical component. What are you going to do? This is for what? Horizontal component. Now, for the vertical component, you're going to use this formula. We have F sine the force multiplied by what? Sine theta. So by sine theta, I'm going to give you the vertical component. It's not going to be degree. And multiply by 30 degree as a sine 30 and multiply by the force. You're not going to get this line that was here to now be facing in this other point. So that's what you're going to do here. So if you do that, you're going to convert it to what? A vertical component. You also convert this one to a vertical component. And once you have done this, you find out that this one here is now going anti-clockwise. This one going anti-clockwise. Whereas this one is going what? Clockwise. Because this one is going to be pulling it to going this way. This one is going to pull it to going this way. So you get this one to be anti-clockwise. You get this one. You get the perpendicular distance. Which perpendicular distance is getting from this edge as well. For this one, let's go with the clockwise. We have 10 multiplied by perpendicular distance is from here to this edge is 10 cm. 10 cm multiplied by 10 plus, all right, plus this other one that is also what? Going what? The clockwise direction. But now you have converted it to what? A vertical component, which is from this is, remember that we have F sine theta converted to vertical, while force on this line, which is 10 Newton. So you're going to have 10 sine 30. Are you getting? And all of these are working for what? Clockwise direction. Now, this is equals to the what? The anti-clockwise force. Where can the anti-clockwise force be? Sorry. We now multiply by the perpendicular distance. So this multiplied by perpendicular distance. So this is just the vertical component that we have gotten. So perpendicular distance will also be gotten from the knife edge. So if from here to here is 50, then from here to here is 20. That means from here to here is what? Is 30 meter, 30 cm. All right. Now this is now equals to all of these are the what? Clockwise. Now the anti-clockwise is this one that is making it a pull here, which is what we are looking for. We are looking for W. Now W multiplied by the what? The perpendicular distance. Still the perpendicular distance from here to here is going to be what? 30. And you're going to add it to what? This other what? One that is also moving into what? Clockwise. Anti-clockwise, I mean to say. So how can we get it? Still the what? Vertical component. It was here before. We have to change it to what? The vertical component. Now, when you do it, you're going to align it like this. You solve it, get the sin theta. Sin 30 is 0.5, or you can call it 1 over 2. Now you solve with it, solve with the other side, and then you can know where your W is, make it sort of formula. And after you're done, you'll get your answer. But if you can't do it, I'm going to be making a video specifically on this particular drawing. So I'm going to make a video on this drawing after this live class, and I'm going to post it on our WhatsApp group. So if you're not on WhatsApp, WhatsApp me on 08153957022, or consider adding +234 if you're watching from another country. So let me know how was the class. I've ended the class just like now. Comment on the comment section how was the class. So thank you guys. Now on TikTok, you're going to be looking at um angle of elevation and deflection. We have two triangles. Thank you for joining the class. Some of you did not join earlier when we explained what we mean by momentum. But when I make this video, particularly, I'm going to explain it again. Post in the comments. Don't forget to subscribe. And always come. I'm going to schedule the live class. Not going to be daily again. It's going to be on the weekend. So you'll schedule it. You come on time so that you're going to get the tutorial. Thank you. We are ending the live now. Say me bye-bye on the comment section. Say bye-bye on the comment section. Say bye-bye on the comment section. Are you still copying the assignment? Is it copying the assignment? Let me know. Okay. So everyone. So I've ended the live. I've ended the live. So see you guys on the next comment if you're just coming now. Comment if you're coming now.